Hey guys, in this video I'm going to demonstrate how to perform a modified Knots test. The very first question is what's the purpose of performing a modified Knots test? The purpose of performing this test is to help differentiate between different microfilaria. Whenever you make it, it creates a concentration of microfilaria, and then if your microscope has a micrometer on the lens, you're able to measure to differentiate between different types of microfilaria. So I'm gonna use these 6 ml white Fat Cat tubes. I'm gonna go ahead and untube them. Okay, I had to make a 2% solution of formalin. I went ahead and measured out 4.5 milliliters. So I'm putting these into each tube. Notice that I am wearing goggles and gloves. Can dispose of these properly. I have my anticoagulated blood, EDTA. I'm going to go ahead and measure out 0.5 and add that into each tube. Hey, bud. Okay, I'm adding that to one. Then I'm going to use a different syringe. Bye-bye. Okay, got that. I'm going to squirt that into this syringe. Okay, I'm going to dispose of these syringes. All out of anticoagulated blood, so I'm going to put that aside. I'm going to recap these guys. I'm going to go ahead and gently invert them. And now, just so you know, always label your tubes. And for this experiment, I have them labeled as modified Knots test. I went ahead and made two, so that way I have two balanced tubes. So I'm gonna press pause on the video and walk to my centrifuge. Okay, I'm here at the centrifuge station. I am putting them in different sides. And I am putting it in between 1,000 to 1,500, 1,500, and I'm gonna close it, and I'm gonna spin it for 5 minutes, and I'll be back in 5 minutes to continue. Okay, you guys, so the centrifuge has stopped, so I opened the lid. I'm gonna go ahead and take out both samples. Got them right here. I'm moving to our wet table. Sorry, this is the ER floor. So I'm gonna place them right here. So I'm gonna go ahead and decant the supernatant. I'm at the wet table. Okay, so I have that left. I'm gonna add 1 drop of the new methylene blue. Okay. Added that. I'm gonna swirl it around. Now I'm gonna use a pipette to move 1 drop onto a microscopic slide. Okay. Now I'm gonna put a cover slip on it, like that. And now I'm gonna go to my microscope. Okay, I'm putting it onto the stage, turning the microscope on. Start it on the lowest objective, raise the stage. Okay, I finally focused on the low objective, so I'm gonna go to the mid objective, and now I'm gonna scan the entire field, and then I'll go to the high objective. So with the formalin and the water that I used to make the solution, they would have lysed the cells. So I'd be looking for any type of parasite or microflaria. And they would be immobile due to the new methylene blue stain. And I'm just changing the fine focus. Okay, scanning through.
So our PCV and
okay, now I'm gonna go ahead and switch over to the high objective.
That was the biggest one that I had noticed.
And I'm gonna look at it. I'm gonna go ahead and scan the slide.
Everybody does that.
And if I notice any type of microflaria, which I don't right now, I would have to differentiate it between the different types of morphology that there are. So like I would look at the tail, I could look at the head, I could measure it if my lens had a micrometer on it, but I didn't see any, so the test was negative for microflaria, meaning there were no heartworms in there in this specific sample. Thank you. Hi y'all, so in this video we're gonna do a manual cross-matching for blood transfusion. I do have two different types of samples for two different patients. One of them is gonna be our donor, one of them is our recipient. I have clotted blood in a red top tube, and then I have whole blood in a ETA lavender top tube. The reasons why we perform a cross-match is to make sure that the blood is compatible with the donor. The donor's blood is compatible with the recipient's blood. We do a cross match so that way we observe if it is serologically compatible, so that way you minimize your chances of a reaction. There's a difference between a major and a minor cross match. When you perform a major cross match, you're putting the recipient's plasma with the donor's red blood cells, and when you're doing a minor cross match, you're flipping it, so you're doing the donor plasma with the recipient's red blood cells. So what I'm going to do now is I am going to go ahead and centrifuge my samples, and I will... Okay, you guys, so I'm at our centrifuge right now. I bought the samples in. They are cross temperature, so that way it's balanced. I set it for 5 minutes at 1,000 RPMs. I am going to close it and start spinning it, and I will be back after, so that way we can separate the different components. Okay, so I have the samples right here. I did separate the clotted whole blood for my donor recipient. It came back as serum, so I separated that. I did label it as Maggie. And then since we're on Maggie still, I need to go ahead and separate the plasma from the red blood cells. So what I'm gonna use is a pipette. Gonna just put that in there. So now I have the red blood cells like that. Gonna use a different pipette. And I am, since Maggie is a recipient, I'm gonna put 2 drops of red blood cells in there. I'm going to do the same thing for Oliver, who is our donor. So right here, I'm going to put the plasma in a white top tube. Our tube labeled donor. I'm going to put 2 drops of the red blood cells. Now with these, I am going to add 3 mLs of sterile saline. So I'm going to remove the needle. And our recipient, okay, remove the needle. This is our donor. Now since these are red blood cells, what I'm going to do is just gently invert them. I'm not going to be very harsh with them, but I do want to mix them. So now I will be taking them to the centrifuge. So I'll be right back. Okay, so I'm back at our centrifuge, and I'm going to be placing the tubes into our fixed head centrifuge across from each other, so that way they balance each other. And the settings, it's going to be blood, so it's going to be close to 3,000 RPMs. And I just need to do it for 1 to 2 minutes. So I will set that at 10 minutes, and I will be back in about 1 to 2 minutes, okay? Okay, so the centrifuge has stopped. So these are my donor and recipient samples. So this is what is considered washing the erythrocyte suspension. So now what I'm gonna do is decant this supernatant, and what I'll do is get 2 more drops of the red blood cells, put another tube, and repeat the process. I'm gonna do this a total of 3 times, okay? So I will be right back. Okay, so I have now finished the 3 washes. So these are my washed red blood cells. So now I am gonna draw them up in a syringe, and I'm gonna I just need 0.02. This is recipients, so it's Maggie's. So I am put that in there. I'm gonna add 0.98 saline. Okay, that's the suspension now. So I'm going to do the same with our donors. And I'm going to add 0.98. Okay, so now I'm going to do my major cross match. So I will be taking 2 drops of Maggie's plasma. Adding that into the major cross mat 2. Okay, and now I will be closing the plasma.
Who thought these were a good idea?
And now I will be, to the major cross match, I will be adding 1 drop of the donor cell suspension.
So let's do this well with the quality. Sure. And you didn't mention go over that with or switch out with Nikki and so she can do it.
Okay, I will mix that and I will put that down. Okay, now for the minor cross match, we're gonna go ahead and get 2 drops of the donor's plasma. 1, 2. Add 1 drop of the recipient cell solution. 1. Okay. Mix that. And now we're gonna do the donor control. So we're gonna add the 2 drops of the donor plasma with 1 drop of the donor red blood cell. Okay. And now for the recipient control, we are going to add 2 drops of Maggie's plasma with 1 drop of her cell wash. Okay, we are gonna go ahead and slightly invert these tubes to mix them. And we're gonna let this incubate for 15 to 30 minutes. Okay, so now I let it incubate for 15 minutes and I have the 4 tubes in the centrifuge. I am gonna go ahead and spin it at 1,000 RPMs for 15 seconds and then I will be observing the supernate. Okay, so all the tubes have been centrifuged for the 15 seconds. I am noticing that the supernatant has no hemolysis. So at this point the controls would be okay. And now for the major and minor controls, I would resuspend the pellet and just look for any agglutination. So So in the major, it is perfect. It is fine. No agglutination in that one. And in the minor, there is no agglutination. So now I will check it microscopically. Okay, now I am gonna be checking the cross match microscopically. So I have my two slides labeled the major and minor. I am going to place one drop of the major and one drop of the minor onto the minor slide. Okay, I have my cover slips, so I'm gonna go ahead and so I have my two slides. I will be going to the microscope and I will update you. Okay, so I'm at the microscope area. I have the major cross match. I'm gonna load it into the stage. I'm gonna turn the microscope on. Okay, I'm gonna start with low power. And now I'm gonna focus it. And right now I'm scanning the slide and I'm looking for any type of agglutination. Okay. So negative for agglutination on the major cross match. Now on the minor. Okay, there is no agglutination, so based on this test, that means that Oliver and Maggie could be a recipient of Oliver's donor blood for blood transfusion. Hey y'all, in this video I'm going to show you how to perform a direct smear. So I have my fecal sample right here. I have sterile saline, cover slips, a wooden tip applicator, and a microscope slide. So the reason you would perform this this fecal smear would be if you had a very small amount of sample, if you suspect the patient may have giardia. So if it has maybe some yellow diarrhea, if it's recently been playing in water. So you're just gonna apply the wooden applicator into the sample. You don't need a lot, just a very small amount. It's very smelly. I'm gonna put that onto the slide. Then I'm gonna go and apply one drop of sterile saline. Oop, did a little bit more. I'm gonna go ahead and mix it. So you don't want it to be extremely dark, but you do want it to kind of contain some. So like that consistency is fine. I'm gonna apply one cover slip. Okay, I'm gonna go ahead and press pause. I'm gonna put this on my microscope stage right now, and I'll tell you what I see. Okay, I just looked at it underneath the microscope, and there was no significant findings at this time. Hey guys, in this video I'm gonna go ahead and show you or demonstrate how to perform a simple fecal flotation. So what we're gonna do is get a sample of our fecal matter. We're gonna get about 3 to 5 grams, which is about a generous Hershey Kiss amount of stool. Gonna put it into the cup with a tongue depressor. That's stinky. I'm gonna go ahead and apply a generous amount of fecal salt. So you can use different types of solutions. I'm using a sodium nitrate solution that is around 1.2 specific gravity. And most parasite ova will have a specific gravity that is between 1.10 and 1.2. So you can use different solutions like a sugar solution, a salt solution, really whatever your clinic has in stock. We have a commercial fecal salt, so it's just sodium nitrate. Okay, so I have that mixed. Now I'm gonna put this gauze square over it and pour it into this cup. And I'm gonna drain that. Okay, and now I'm gonna use this really cool little device. The reason why we would do a simple fecal flotation would be if the owner, maybe for an annual visit, if the owner is saying that they've noticed maybe some different types of ova in the stool sample, like little rice.
We had one of the bag spikes stopped working, so I had to, they're both still sterile, but I had to split them into bags.
So I'm placing that in there. Okay, I'm gonna apply a little bit of the fecal salt just to make a meniscus. Okay, and now I can either place a slide or a cover slip. I am actually gonna do the slide, and I'm just gonna place it across the side down, and I'm gonna leave it undisturbed for 15 minutes. So I'm gonna start that, and I'll come back when it finishes. Okay, so our time is up, so I'm gonna go ahead and flip this over, and I will be placing a cover slip onto the slide. I will put this on my microscope stage, and I'll be back and tell you what I find. So I did look at it underneath the microscope. I scanned it at the low objective, and then I went back on medium objective. I found some debris, but I didn't see any ova parasite eggs. So at this time, I would mark this no significant findings. Thank you. Okay, in this video I'm going to be explaining how to do a centrifugal flotation. So it is going to be very similar to the other test. You'll perform this test if you do it regularly in your clinic. I remember my very first practice that I ever worked at. We used to do this all the time because the centrifugation helps catch other ova parasites. So you're gonna take a small amount, about the size of a Hershey Kiss. I'm gonna add some fecal salt.
Having fun?
Oh yeah. It's my favorite thing to do about being a technician. Okay, I'm gonna mix it. It's very stinky. Also, while you're mixing it, you can also kind of do like a gross examination. If you notice anything peculiar in there, you might want to look out. Okay. Place that there. Okay. I'm now gonna use this. I'm gonna pour this into the tube.
Yes, definitely.
I'm gonna fill this up to about 1 centimeter up to the top. I'm gonna go ahead and put the lid back on. I am gonna go ahead and fill up my second tube so that way I have a balance. Okay, about 1 centimeter. Okay. Now I have these two samples. I do have a fixed head centrifuge, so I'm doing the modified version right now. So I will go to my centrifuge and I'll continue. Okay, so I do have the two tubes. I'm gonna place them into the fixed head centrifuge across from each other. On the settings, I am going to put it in between 1000 to 1500, and I am gonna close that and I'll run it for about 5 to 10 minutes. Sorry. And then I'll come back and I'll show you the next step, okay? Okay, so my samples have finished being centrifuged. There's a nice little pellet at the bottom. That's kind of just all the fecal debris. So I'm gonna untop them. What I'm gonna do now is I'm gonna top them off with fecal salt. I'm gonna go ahead and create a meniscus. Okay. And now I just have two samples just to have more. I'm gonna place the slides on there and I'm gonna give it 10 to 15 minutes. So I'm just gonna do 12 minutes on the timer and I will be back in 12 minutes. Okay, it's been 12 minutes. I'm gonna just get one of these little slides and pop it on. Sorry, it's getting a little loud in here. It's our overnight crew. So I'm gonna put this on the microscope stage and I will examine it at 100 or mid magnification and see if I see anything. I'll be right back. Okay, so I just got back from looking at it on the microscope and there was nothing on the slide. So no significant findings at this time. Hey guys, in this video, I'm gonna be showing you how or demonstrating how to perform a fecal sedimentation. This type of fecal test is usually performed to find different parasites and ovas of very large parasites, particularly the fluke worm. So this one is probably the most laborious of all the different types of fecals that you can perform. So let's get started. I didn't have a 50 ml conical centrifuge tube, so I am using a 60 ml syringe cap. I am grabbing my fresh feces sample about 2 to 5 grams. So as my other videos I said, that was about a big Hershey Kiss. I'm gonna go ahead and pour about 30 ml. So since this is a 60, I'm gonna go halfway, and then I'm gonna go ahead and mix the sample. And I'm using a fecal loop to help agitate the sample and get it nice and mixed to make it a homogeneous solution, meaning that it's one solution. It might not be homogeneous, it might be heterogeneous, but we'll try our best right now. One thing that I didn't point out in my other videos that I really did want to point out is whenever you're performing a fecal, you do want to make sure you educate the client to let them know that the freshest sample is always the best sample. So, you know, let's say a client brings you a sample and they said, oh, it was in my yard. It could be from last year or to last night. We would just say, oh, that sample is probably not going to be the best sample because different parasites do respond differently. In particularly tapeworms or the proglatids, they could migrate out of the feces and spread elsewhere. Giardia, maybe it is dried up already, so there wouldn't be any of that in the feces matter anymore, so you wouldn't be able to do the very best fecal. Okay, so I have that. I got it pretty mixed up, so I'm gonna put the fecal loop down. I cut a gauze square into four sections just to use as a type of cheesecloth or strainer. Now what I'm gonna be doing is pouring this solution with the gauze over it to strain it into another syringe casing. So that's gonna kind of help get all of, I believe you would call it like the gross sample or the macro, the stuff I couldn't mix. And there's still, what I'm gonna do now is actually probably put that down. I'm gonna try mixing it a little bit more just so that way that can go through the strainer. Based on how laborious this actual fecal test is, I don't think many day practices would actually perform this, because for one technician to perform this very long procedure, maybe in between rooms, maybe, it would just be a lot of resource for one test. So I think that I work in an ER. I think it might be better use of resources if maybe the DVM were to maybe just send out a sample so that way a referral lab could do it. But if there were any cost restrictions, then I could see why the clinic would do it. Now what I'm gonna do is I'm gonna go ahead and supplement the tube with water with my graduated cylinder. Okay, I'm gonna set this in a cup. It's a pin holder. I'm just using it right now to help that. I am gonna leave this. I'm actually gonna move it right now to a flat surface instead of a non-flat surface, and I'm gonna leave the sample alone for about from 15 to 30 minutes. So I also have a timer. So I'm gonna click it to 15. Oh, I reset it. I'm actually going to set it to 20 just to kind of give me a middle. I'm going to press start. That is going off, and I will be back in 20 minutes. Hey guys, so it's been, I gave it 10 minutes more, so it's been about 30 minutes. That way the camera does see there is some sedimentation down here, so what I'm going to do is decant this entire container and try my best not to disturb the pellet at all. Okay, so I'm decanting now. I am at a wet table, so that's why I am pouring it down. I'm sorry, y'all. I am in dog ward right now at a wet table, and one of our patients does have really bad anxiety. Okay, so now I'm gonna resuspend that with some more water. And I will be placing that in this holder. It's okay, Lexa. Lexa is actually a neurological case. She's presenting for a neurological illness or deficit. She did have neurosurgery. Okay, so I am gonna leave that there. And what I'm gonna do is actually repeat that. This was my first time, so I'm gonna repeat it 2 more times. I may be recording, I may not. But I will be back in 30 minutes. Hey guys, I'm back. So this is now my 3rd time resuspending the sedimentation. So I am now gonna pour it out. Okay, there's the sediment, and I'm gonna press a quick pause and I'll be right back, okay? Okay, I'm back now. I did have to do some manipulation of supplies because I don't have a very long pipette. So because I had this, I basically cut with some really big bandage scissors. I cut this down so that way my pipette would fit. I'm gonna go ahead and suspend that sedimentation, and I'm gonna go ahead and put that back in the container. I'm gonna grab my frosted slide. I'm gonna make sure to feel for the kind of smooth side, which is this side. I'm gonna apply 1 droplet onto the slide. I'm gonna go ahead and put my pipette back in there. I'm gonna grab my cover slips. Okay, I'm gonna apply this onto the slide, and I'll be right back. I'm going to the microscope. Okay, I'm at the microscope, so I will load the slide. I am going to read the slide and I'll be back. Okay, I'm back in dog ward. I went ahead and read the entire slide at 100 magnification, and I did not see any presence of ova or parasites at this time. What I will do is go ahead and repeat it with the rest of the sedimentation until I have scanned the entire contents of the sedimentation, so that way I could check for possible fluke ova. One more point I did want to point out is you notice that these are like my 5th, 6th pair of gloves while I was waiting. Anytime that you're performing fecals, you should always be wearing gloves. Make sure that you're not touching your face at all. Make sure that you're not eating. And you should never be performing fecals in an area that there is any type of food that you may eat. I remember back when I used to work in general practice, behind the exam rooms, we had our lab station, but we also had our little kind of break area where we would rest, and we always had snacks that we would pop in, and you can really harm yourself if you are ingesting food while performing tasks that could potentially harm you and infect you with parasites.